0, which is equal to 8.
Okay.
I object to that. You have to prove that 0 has no number first, then you can say that.
Yeah.
That isn't imaginary.
Yeah. So Andreas, I want to see your eyes. You've been looking down a lot. And I want to.
I'm sorry. I'm cutting mine.
Oh, you are. Okay. Good. So, Ethan, do you guys see what Ethan just did? Ethan just said that if you multiply 0 by something, you can't ever get 8.
Yeah.
That is actually not a bad proof. Now, Andreas, you didn't love the proof.
Real number.
Why is that? And Andreas, can you just stop cutting for just a second? And why is it, Andreas, that you didn't like Ethan's logic on this one?
I don't like the logic because like 8. You have to prove 8 divided by 0 is undefined. Then you prove that. Then you can do that.
Well, wait a minute. But why don't we just call it X? Why don't we just call it X? And if we cross multiply, we know that 0 times X has to equal 8. And can you come up with a real number for X that would work? And the answer is no. So I actually am persuaded by the logic, but I want to show you something else. And Kathy, I don't see you anymore. Audrey, I don't see you anymore. So try to be visible there and let me share with you my proof. This is my proof. You guys ready? So everybody say it out loud. 8 divided by 2 is what?
Is 4.
So 8 divided by 4 is 2. 8 divided by 2 is 4. 8 divided by 1 is?
8.
8 divided by a half is?
16.
16. Oh.
Divided by a quarter is?
32.
So guys, do you see that we are approaching positive infinity here?
Yeah.
And what are we approaching in the denominator? We are approaching what?
0.
So as you approach 0 in the denominator, you are approaching infinity as a quotient, and infinity is undefined. Now that's my proof. That's my proof for why you can't divide by 0. But it's a really, there are a lot of people that disagree quite a bit. Now, I want to pick up on something Seth talked about, okay? When Seth threw at me the a minus 0, I was kind of inspired by that because I was wondering about the 0 property that I missed here. Does anybody see a property that I missed that would give us 0?
0 times a.
It's a really basic one.
8 to the 0th power.
No, that's 1.
That's actually 1.
No, that's 1. Yeah, never mind. That's 1.
We'll talk about that in a second. But that's a weird one. Now watch this, guys. How about a minus a?
Oh, wow. Oh.
That's a really, really important one. And guess what? It doesn't work for a certain number or a certain concept.
Infinity?
What do you guys think of infinity minus infinity?
Infinity.
0.
It's infinity because infinity it goes on forever. So it's like
you said infinity or undefined. A has to be a real number.
You know, guys, I have to tell you something.
He said A has to be a real number.
I think about half the mathematicians out there believe that infinity minus infinity is infinity, and half the mathematicians out there believe that infinity minus infinity is 0. Now, I used to be, and I'm going to say used to be, I used to be in this camp. I used to be in the infinity camp. I am open to being persuaded that it's 0. And who can give me a good argument to why it's 0? Audrey, go for it.
Well, usually whatever number we don't know what it is minus whatever number, it usually ends up being 0 because you're taking that amount of things from that amount of things.
Yes. So you're saying, Audrey, that every real number A minus itself will always give you 0 no matter what. And so I like the argument. Seth, what do you think?
Infinity isn't a number, so it can't be in an equation. So it can't be 0 or infinity.
Wait a minute.
It can't equal infinity either.
Oh, wait a minute. Whoa. Hold your horses, mister. You're telling me that infinity doesn't even equal infinity?
Infinity equals infinity in a non-math concept.
I think it's undefined because
Infinity as a word, not as a number, equals infinity.
Okay, I agree.
Infinity as a number could equal anything.
Now build on that, Ethan M.
Well, I just think that I think that infinity minus infinity is undefined. Because I think there's so many answers.
Well, here's one of my proofs for why I was in the infinity camp and the undefined camp. One of my proofs is that infinity plus 1 is
infinity.
Infinity, yes?
Infinity minus 1 is still infinity.
But one could also say that infinity plus 1 is 1. Because infinity can technically be anything, right?
No, it cannot be anything. Infinity is literally the
highest number possible.
It's no. It's not.
Not a number.
It's the concept of an infinite group of numbers. Now that can go from negative infinity all the way to positive infinity. And this is the way you would write it in parentheses with a comma. And this is literally all real numbers, okay? But if you take Audrey's comment and you say infinity plus 1, take away infinity here, right? Because if they're equal, then you would end up with 1, okay? So this is a really, really difficult, I just don't think that A minus A equals 0 applies to infinity for this reason. I
think that, well, what's infinity minus 1 then?
Oh, same thing, my friend. Infinity minus 1 is also.
Then when do you eventually get to numbers that we have identified?
You don't.
You don't. You know what you do? You take numbers like 10 and you give them ridiculous exponents, and then you even give them ridiculous exponents upon that, and all you have is a bunch of ridiculously large numbers which will never equal infinity. Now, I want to go back to something that Ethan G mentioned. So Ethan G mentioned, and I call these advanced properties. These are for you guys. A to the 0th power equals 1, as long as A is not 0. So 3 to the 0th is 1. A to the 1st power is actually another what kind of property? And Kathy, what kind of property would you say that guy is?
Identity.
Right. Isn't that another identity property where you start with the number and you end with the same number? Kind of cool. So they don't really call it an identity property, but I do, because it is an identity property. Then you got the square, you got the cube, Then you get into something called rational expressions. Rational exponents are fractional exponents. So a to the 1/2 power is the square root of a. A to the 1/3 is the cube root of a. 1 to the 8th power is always going to be 1. Now, is that true of 1 to the 3.2 power?
Yeah,
Why?
right? Because if wait,
What's
no,
1 times?
because if
Oh,
you do
oh.
1 times 3, that's 3. That's 1. I mean, 1 to the power of 3. That's 3, and then
No, that's 1. 1 to the power of 3 is 1.
Oh yeah, and then
1 times 1 times 1.
that's 1/5, and then it's and then you take the 5th root of 1.
Do me a favor, guys. Can you give me 3.2 as a fraction, as a proper fraction?
A mixed
Improper.
3 and
Improper?
1/5.
Improper.
16/5.
So it is 16/5. Now, if you do 1 to the 3.2 power, would you agree that that's the same as 1 to the 16/5 power? Yes?
Yeah.
Now, this is an important property for you to know. This 5 represents the root. 16 represents the power. So can you guys, wait, hold on. Can you please take the 5th root of 1 and hold it in your mind for just a second? The 5th root of 1, what number times itself 5 times will equal 1? On 3, 1, 2, 3, say it.
1.
1. And what is 1 to the 16th power?
1.
And that is a proof why 1 to the 3.2 equals 1. All right? It will always equal 1. Now, you need to know this property, which is called the rational exponent property. And that is this little c over here, this denominator, that's the root. The numerator is the power. Now, believe it or not, there was this teacher that I worked with 20 years ago, okay? Her name was Galt. And Galt said, hey, I got to have an easy way to remember this. You ready? The bottom of a fraction is kind of like the bottom of a plant. It's the root that goes into the ground. And the top of the fraction goes to the sun, the power. So this is the base to a power over a root. And so we have the nth root and the p power. So anyway, I thought that was a really good way for me to remember the power and the root. Yes, sir, Seth. On
the top one, on the one we were looking at? No, before. The b in the root, is that supposed to be inside it over the a, or over the whole root entirely?
Yeah, Seth, I love you, man. It's a great question. It can be in either place. So it can either be inside or it can be outside. And let me just give you a little proof for that, because don't take my word for it, okay? You ready? If I wrote for you root 5 and 1 to the 16th.
Oh yeah, still 1.
You guys agree that 1 to the 16th is still 1 and the 5th root of 1 is still 1.
But that's because we're assuming a is 1. What if a is different than 1?
Well, Very,
Well,
very
this is the
different.
properties for 1, right?
Now, you guys are going to like this.
Yeah, but in the
Okay.
other one, you just wrote A.
Okay, watch this.
Oh,
Take 8 to the, hold on.
booga
Take
booga.
8 to the 2/3 power. Who can tell me what that is? No calculator. No calculator. In fact, if you could send me a chat answer on this one. And I'm going to write it out as the property. Remember, 3 is the root. The 2 can be inside or outside, doesn't matter. What do you guys
Wait,
think on 3?
it doesn't matter?
It, as I said to you before, it can be here or it can be there.
It can?
It can. And I'll prove it to you in just a second here. Or actually, I'll prove it to you right now.
4.
What is 8 squared?
64.
And what is the 3rd root of 8?
4.
Nope.
2. I mean 2, yeah.
So
And then
guys,
square.
check it.
But you wrote 2 cubed instead of 2 squared. You
Oh.
wrote
Yeah.
Thank you, Andreas. So 2 squared is the same as 64 cube rooted, which is 4. Did you guys all get 4? Ethan, you got 4?
Yeah.
Oh, nice, nice, nice. Very, very, very nice. Let's do another one. Let's do 16 to the 5/4 power.
16 to the 5.
And I'll write it out for you.
Mr. Kramer, I find it much easier to do the square root first in this one.
Oh.
Yeah.
So you're saying you would rather have the power on the outside?
On this one.
Same.
You know, Andreas, I wonder if that might not be a best practice all the time. I'm almost thinking that, you know, when Seth raised the question, but I kind of agree that on the outside might be easier. Did you guys get 32?
Yeah.
Yep. Well, sometimes, like, if, like, say the root, it didn't go in, like,
What are the 5th?
there was, like, the 5th root of 16, but then the root outside, it was like, some number, and then you multiply, if you do that to the 16, then it will be, you could, do the 4th root of it.
Right, right, right. I mean, look, guys, does anybody have a
You get
calc handy?
No.
Can anybody do 16 to the 5th power, please?
I got it.
It's going to be ridiculous.
16 to the 5th.
5th power, yeah.
It is 1,048,576.
Mr. Kramer, I did it without using a calculator. I just did 2 to the 20th.
Oh, right. But let me ask you this, guys.
And I didn't use a calculator.
Now, do you think that taking the 4th root of 1,048,576 is an easy job? And the answer is no. It would be ridiculous. There's no way. So I would say to you that you should always do the root first, followed by the power. And that's my conclusion right now, but I could be convinced otherwise. Now, I am looking for, are you ready? Multiple, elegant,
Like,
Solutions.
Salute? Oh, solutions.
I do not want just one solution, and I don't want an easy one. I want elegant. Now, in the game that we're going to play, most kids will use addition, subtraction, multiplication, and division. You guys are going to be allowed to use exponents, square roots, cube roots. You could do a to the 0th.
Can we do factorial?
Oh my God. Why not? A factorial? Absolutely. I love it.
Can we do
Double factorial.
can we do addendorial?
Basically the same thing.
What is that?
They're
Oh,
different.
Seth?
Addendorial,
Thing.
instead of multiplying them all together, adding them all together.
So if you did the addendorial of like 7 addendorial,
Oh,
It would be 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1.
Hmm.
basically triangle numbers.
but hold on a second.
Oh, wow.
Seth, but it doesn't come with an exclamation. What would be the symbol?
Question mark.
Addition!
An
Exclamation.
up,
Question mark.
a down, exclamation.
Or did you just make it
Button
up?
at the
Write
top
down
and then a little
exclamation.
exclamation.
I mean, that's a really
It'll be
cool,
in addition before the exclamation.
like this?
Yeah, like that.
No, a plus with a dot under it.
You know, that's like the coolest thing I've ever seen. Okay, so thank you for that. And here's the game. You've seen the game, but we're gonna play it for elegant solutions. So the way the game is played, and let me
Is
just
it
give
go
you-
fish?
Oh, it's better. So here is
Oh.
6 solutions, only 2 of which
Oh, I've played this game.
are elegant. Now watch this. Oh wait, somebody's making a shuffling noise, so I'm gonna just mute everybody. The game is played with 6 cards. You have to eliminate the jacks, queens, and kings from the deck. Just take them out. You don't have to throw them away because you might want to play regular cards. When you remove those 12 cards, forget the jokers, you have now 40 cards that are not face cards. Ace through 10 times 4 suits. That's 40 cards. You can play 6 rounds because it's 6 cards per round. The first 5 cards, you work with the operations, and your target number in this situation is 8. So now I'm going to unmute everybody. So stop shuffling papers for a minute here. And
Is it always 8?
no,
No.
it's whatever it is. So just listen. In this situation, I randomly chose 5 cards and a 6th card, which was my target. Now I need to get to 8. Notice, Audrey, about the usefulness of the properties. So I first used, this one was, what was this? 4 minus 1 and 10 minus 7, both of which were 3. And then 3 minus 3 is 0. And then 0 plus this 8 was 8. I did the exact same thing here, but instead of getting 0 by 3 minus 3, I did 3 divided by 3 to get 1, and then I used multiplication instead of addition. Here, I took a completely different approach. I subtracted 4 from 10 and then added 2 by using 8 minus 7 plus 1. And then the same thing here. These were more difficult. Here, I actually multiplied. It's much harder to go with large numbers. And then I divided it by 10, which was 7 plus 4 minus 1. Here, I got 56, and I needed to divide that by 7, and I got 10 minus 4 plus 1. So I'm going to be looking for not just one solution, but I want you to chat to me multiple solutions here. Ethan,
Do all of them have solutions?
wait, say it again, Ethan G.
Does every configuration have solutions?
Ethan,
No.
Ethan, that's a great question. I have never found a group of 6 cards that I could not solve. That doesn't mean that you won't be able to find one.
I always do that with what time it is.
Can you guys tell me how many combinations of 6 cards there are?
Billion.
6 take 1. 6 take 6.
I don't know.
Wait, is it 42
1, 2,
six?
3, 4, 5, 6, 7, 8, 9, 10 million.
6 to the 6th.
I hear you.
100,000.
I hear you, but I don't completely agree.
I found an
10,000.
elegant way to get the target of 8.
6?
I think it might be 10,000 times 81. So it may be
810,000.
yeah, because remember you can only have 4. There are only 4 numbers of every suit, so you can't have 5 of the same. So you have to eliminate some. So I think it's 810,000 different combinations. So Ethan G, I have not tried all 810,000 combinations. Now, Ethan M, you still have a question? I'm sorry.
No, I have a way for the example one.
Oh, you have another way. Awesome.
Yeah, I have is ace 1.
Ace is 1, yes.
So the 10 plus ace plus 7, that's 16.
Wait,
10
plus-
10 plus 7 minus 10 plus 7 minus ace, which is 1, and that's 4. And then can I do and then so I have 16, and then can I do 16
wait, hold on. So you have 16 now. Keep going.
can I do the square root of 16 and then plus the 4?
Yeah, why not?
Yeah.
But you'd never use where
But there is no 2.
yeah, where are you gonna get you've used your ace, you've used your 10,
Oh,
you've
but I
used,
haven't used the 8.
hold on, you've used your 7, and you use the square root. Oh, wait a minute.
Oh,
Wait, look, guys. You see the 4 and the 8?
Yeah,
He
8 minus
oh yeah.
square root 16 to
Guys,
4 to the 8th is
Yeah.
4, not 8.
So do you see what I'm looking at is if you use the 4 card and the 8 card, you get 16 to the 1/2 power, but that's only 4. So you're a little shy.
You could do square root of 16 plus 8 minus 4.
So 16 to the
No.
4/8 power. Keep
But
going.
then you're using your 4 and 8.
No, square root of 16.
Yeah, I know, but
That's not using either of them.
but where do you get your square root? You need to use the 4 and the 8.
Use your 2.
But isn't the square root an equation just like a thingamabob, just like plus and minus and times and divide and
Yeah,
exponent?
no, it's not because because Seth, if I said to you 10 to the 4th, you have to use your 10 card and your 4 card to get 10,000. Okay, so here's what I'm going to show you right now. I'm going to introduce you to another version of one of my favorite sites. And I sent you the link. It's called random.org. And
Yay.
I programmed it to take out the jacks, the queens, and the kings. And it will yield only 6 cards. So I'm literally going to now grab these cards, and I want you guys to come up with elegant solutions.
Oh, I could do that with
But Seth, don't think out loud, and if you want to share, just raise your hand electronically because I want to hear everybody. And go, guys. 10 is your target. And I want you to send me a text with your solutions and then keep going. Find 50 solutions if you can. And Audrey, are you still with us?
Yep, I still am. There was some
Okay.
background noise.
Oh, thank you. So guys, pick up that pencil. I don't want to see anybody doing this in their head. There was one kid in my class, oh my God, he would not pick up his pencil and he didn't solve one. And once he picked up his pencil, oh my God, he started solving. So Ethan, you have to actually put it in the chat. And I'm trying to follow Kathy's right now. It's 2, and then 2 minus 1 is 1. And then that's brilliant. Kathy, that was awesome. Guys,
Wait, do you need the number of the exponent to do you need the number of the root to take the root of it?
yeah, to take the root of it, you need a 1 and a 2, or a 2 and a 4, or a 3 and a 6.
Twice or something?
Say again?
Did you use 10 twice? Because like 10 minus 8 is 2, and then use 10 again to multiply.
No, because 8 plus 2 is 10.
Yeah, yeah. Kathy,
Okay, so
Kathy got the 10 from the 8 and the 2. Kathy, that was really, really pretty and
but
elegant.
Mr. Kramer, I sent you mine.
Oh, good. Andreas, can you verbalize it to me?
So the quantity of 8 minus 8 times the quantity of 2 minus
Wait. But you have to go at a speed in which I can actually write it down. So,
quantity of 8 times 8 minus 8.
okay, so you did 8 minus 8 first. Go.
And then I did 2 minus 1.
9.
And then I added them, and then I multiplied them 1 and 0 together.
1 times 0, 0. Go.
And then I added 10.
Love
Or
it.
you could do 1 plus 0 and multiply it by 10.
Yep.
8.
Or
Absolutely.
0 plus 1.
That's absolutely correct. Who's got an original approach here? Anybody have a different approach? Keep working it. And guys, these are really, really fun and challenging, in my opinion.
2.
100. Yeah, 100.
12. 11. That's so close.
No.
2.
Okay.
20. 8. Minus 16. No. Not 20. 12.
Oh, I got one.
Go for
Hey,
it.
I'm 1 off.
The quantity of 8 minus 8 divided by 8.
8.
Nice.
And then
9.
oh, he already did that, didn't he? Yeah, never mind.
What do you mean? No, nobody did this yet.
8 divided by 8 plus the quantity of 2 minus 1 times 10.
Oh, I got one.
Wait. 2 minus 1, but then you have to do 2 minus 1 times 1, correct? And then 1 times 10.
Oh, yeah.
Okay. Nice job, Seth. And Ethan.
Mr. Kramer, I have a very complex solution.
I want to hear it. So we're gonna go Ethan and then Andreas. Go.
So you do 10 times 10.
Where did you get the other 10? You have to say 8 plus 2 is 10.
Yeah, 8 plus 2 times 10.
And then times 10. Good. Now we have 100.
Oh no, that does not work.
Okay, so I
Wait.
Wow.
Hold on. So do you want to amend it or do you want to come back to it?
Amend it.
Okay.
10.
Amend it. Go.
6 point. I'm trying to like 10. If you can do, if there was another 10 you could work with, like 10 times 10, that you can get 100, multiply that by 1, and then you can take the second root of that.
I actually tried.
9.4.
I tried to get there. I really did. Andreas, give me yours while Ethan's working on his.
Times 8,
Um,
80
so you take 10 minus 2,
plus 2.
Okay, that's 8.
and then you divide that by 8.
did it. Oh, yes.
Okay.
Thank you.
And then add
And
1.
then you add 8 to it,
10
And
times
add 1.
8
and then you add 1 to it.
equals 80.
I love it. I love it. That's very, very sweet.
80.
Guys, you ready for another one?
I have one.
No, wait. I want to keep
Oh,
doing
Will,
this. This is fun.
wait. William first. William first.
I did 10 times 8 equals 80
Whoa.
divided by 8 equals 8.
Equals.
Oh
10.
no, I didn't do it. No.
No. You got it.
Equals 10.
Hold on. Wait.
Times-
Set. Hold on. Will, bring it home. Bring it home.
I
You
can't
can. Look
put
at the 2 and the 1.
2 and the 1.
Come on.
Minus 1.
Times the quantity of 2 minus 1.
There you go. Nailed it. 10. Beautiful. I knew that's where you guys were going, Seth. Good.
Wait,
Audrey, where are you? Do you have anything for me? Audrey, are you working on that?
Yep, I still am.
Okay, good. Ethan M.
Wait, I just need to check that it's right.
And I am going to be looking for
But, oh no.
Okay, can we do another one?
1 times.
absolutely.
Oh no, it's 1.
I got.
Target
Yay,
number 1.
fun.
What is it now?
Is the target number 1?
The target number is 1.
You kidding me?
I am not kidding. So the target number is 1. And
2,
hey guys, I'm wondering,
4.
I am thinking this could be a great opportunity for a very elegant solution.
That's easy.
Maybe.
I got one. 5 minus 4, the quantity of 5 minus 4 to the power of 9 to the power of 6 to the power of 2.
That's beautiful. Now, guys, I want you to watch this. Ready? By the way, Ethan G, that was property beautiful. Now watch this, guys. 4 plus 2 is what?
6.
6 minus 6 is what?
0.
And then, how about 9 times 5? What's that?
45.
45.
And what is 45 to the
To the
0?
0th power.
1.
1.
All right.
So,
Mr. Kramer, I came up with a elegant solution.
okay, and I want to hear yours in a second. So, ladies and gentlemen, whenever you have a 1 as a target number,
So easy.
always try to come up with a 0, or as Ethan G did, come up with a 1, and you could do the 1 to any power, or do any number to the 0th power. So
Okay, Mr.
really cool. Andreas, go.
Okay, so
I have an elegant.
so 5 factorial minus 4 factorial.
Whoa. 5.
5 factorial divided by 4 factorial. Yeah, divided by divided by,
Isn't that 5?
and then divided by the quantity of 2 plus 9 minus 6.
Divided by the quantity of 2 plus 9 minus 6?
Divided by 3.
Oh my God.
Wait.
Andreas, that was insanely beautiful. Oh my God, guys,
Oh.
like that's amazing. So Ethan,
Cool.
gee, I didn't think anyone could do better than yours. And then I was like, what? So I still think yours is beautiful. but Andreas's factorial
Beautiful.
blew me away. Also,
I have
these adenoreals, I gotta learn about that, Seth. And Ethan M.
so
I made it up.
to do
I know
4 squared,
4 squared.
16. So that's 16, and then 16 minus the quantity of 6 plus 9, which is equal to 1. And then 1 to the 5th power is 1.
Wow. That
I
that
got
was
one.
sweet. Who's I?
Seth.
I, Seth.
For the quantity, the quantity of 4 plus 5 divided by 9 is 1.
Oh!
To the 6th power to the 2nd power.
That's absolutely beautiful. Now, guys, oh yes, Ethan.
Okay, so 2 plus 6. I don't know if it's elegant or not, but 2 plus 6, that's 8, and then minus 9, that's minus 1. And then minus 1 plus 5, and then divided by 4.
Ah! Okay, Ethan, very elegant, very sweet. Now, guys, I am really, really excited about this, and I want you to listen for a second. What I want you guys to do is this. I want you to cut out your cards. I mean, it's a little silly because most people have a deck of cards. But take a deck of cards, get rid of those jacks, queens, and kings. Say, mom, dad, brother, sister, get your grandparents on the phone. Say, we're playing this game. And if you're doing a Zoom call, go to my link for random.org, and you can actually generate those numbers. And then whoever comes up with the solution first gets 6 points. So you can play it like that. You can make up your own rules. You can say, well, you get 6 points for every different solution you come up with. And I think that would be even a better way to do it. And then, of course, you know that I'm expecting Will, you, and your dad to work on a program for this.
Solve it?
So,
I don't remember this time.
so Will, will you take that on maybe and give it a shot?
Yes.
Okay, great.
I
So
can
guys,
try and do it by myself in JavaScript.
you know,
Yes, that's no JavaScript.
you know what though? I think it's great to work with parents when it comes to this, because this game, every time I play this with parents, they absolutely love it and they can't get enough of it. So it's something you should maybe bring with you in cars when you're going places. Really, really fun. So I gave you a lot of different puzzles to solve. And then you can see on the bottom, can you see the random.org?
Yeah.
So you kind of have to because I programmed it, if you can't copy that, then you can just create your own. So I want you guys to have a lot of fun this week. Can you guys do a sequence for me from negative 117 by prime number 13? Go.
Negative 107.
17. Negative 100
and
4.
4 negative
negative
9.
91.
1.
Negative 70.
Negative
78, negative
68,
negative
Negative 42.
42,
Negative
negative
29.
39,
Negative
negative
Kramer, I said mine is
26,
bad.
negative 13,
Because
negative 0.
it's basically I'm trying to go faster.
Now, Andreas, do you know that you actually said negative 0, 2, 4, 6, 8? Who do we appreciate properties.
10,
Properties.
12.
Go properties. I'll see you in 167 hours. This is
Ah.
6,
It's
8,
always-
we appreciate 10, 12, 14, 16.
I'll see you guys in an adenoidal number of hours. See ya.
Bye.
Bye.
Say goodbye to your buddies.
Oh,
Bye.
I have the puzzle pieces, but I don't know how to put them together for making in JavaScript.
All right. Bye. Thank you.
Bye.
Bye, guys. Thank you, Ethan.